Here's integrated 3. It's problem 7-14. It says consider the function y equals 3 times x plus 2 squared minus 7 as you complete parts A through C. How could you restrict the domain to show half of the graph? So this is a parabola, and I want to restrict the domain to show half of the graph. So I know that parabolas have this shape like this, and I actually sketched this exact parabola because I knew this is y equals a times x minus h squared plus k. So I knew that the vertex would be at, this is going to be -2 and -7. So I know that's my vertex, and I know it has the stretch factor of 3. They're asking me to show half of the graph, so I can either show the right-hand side or the left-hand side. I think I'm going to restrict my domain and show, oh, here's a highlighter, show the right-hand side of the graph. So what would my domain be restricted to? Well, the middle of the graph is at x equals -2. So I'm going to, and I said that I just want this yellow part. I just want this half. I have a choice of which half I want. I just decided to do the right-hand side. So my domain is going to be x is greater than or equal to -2. And then letter B says, what is the equation of the inverse function for your half graph? The inverse function. What is the equation for the inverse function? So inverse function, I have to take the y and the x, and we know on inverses the y and the x like change places. So I put x where the y was and y where the x was, and then I solved the equation for y. So I added 7 to both sides, and then after I did that, I divided both sides by 3, and then I square rooted both sides, and you know we get the plus or minus when we square root over here. And then I subtract 2 from both sides, and I get y is equal to -2 plus or minus the square root of, well, this is my inverse equation, x plus 3 over 3 equals y. So I need to figure out which one is it that I want. This is the line y equals x right here. I actually wrote this, I actually have this on Desmos so that, because it's going to be too ugly if I draw my sideways parabola will probably be over here somewhere. And then I have to figure out which part of the sideways parabola is going to be associated with this yellow part. Let's look at Desmos so we can figure it out more clearly. Here's Desmos. Okay, so this red graph, that's my original graph. But I restricted the domain, so what I actually want to do that's the piece of my graph that I want right there. And this blue line was just like the middle of the graph. This green line is the special line y equals x that I'm going to reflect across. And then this one is the inverse. That right there, that's my inverse. See, I just typed it right in. And I can see that for this red graph, I can see that this part, the top half of my inverse graph, is the half that I want. So what I'm going to do is restrict my domain, and you can do that by going to the curly brackets, or the braces, and I want to say that x, see I want to like, well actually I want to restrict my range. I want to make it so that this bottom part is gone. So that means I don't want y, I want y to be greater than or equal to -2. See if I can get where I'm going. Oh, it did it. Okay. So let's get rid of this. So now you can see this red one was my original parabola, but it's just, I chose the right-hand half of it. And then this was the top of the sideways parabola. And so now and this is just the line y equals x here. So now I can answer questions. I think the question that they asked me was, what's the equation of the inverse for my half graph? Well, that was y is greater than -2 plus square root x plus 3. And then letter C says, what are the domain and range for the inverse function? So here, this blue one's the inverse function. The domain is the x values, and this is -5, -6, that's -7. So it's going to be x is greater than, I'm writing it down, x is greater than -7, greater than or equal to, and y is greater than or equal to -2. I'll put it back on my document camera so you can see. So domain, range, and let's make sure I did that correctly. Yeah, that's right. Okay, so you had to choose which side of the parabola, and that kind of makes your answer, it depends on which side of the parabola you chose.